it tells you what it's looking for. If it gives you an angle, they want the name of the arc that that angle makes. Otherwise, it's going to say, give me this arc. In this case, it says it wants the major arc that is made by this angle, the major arc, because remember the angle makes 2. All right, this angle is IQJ. If it had asked for the minor arc, you would have given me this one, but they specifically said the major arc. So because they asked for the major arc, we are going to do, remember the major means the arc that is greater than 180. So you're going to give me this arc. You can name it 2 different ways in the order, but the 3 letters you use are J, H, I. You need the arc symbol. You could have said I, H, J, but it does need to be in the order that you would walk around the circle. So all it's asking you for on these is to name either the arc or the angle. If they give you the arc, they want the angle that makes it. And then if they ask for the angle, then they are wanting the arc that makes it, okay? So like number 2, they gave you the angle. They want you to tell what arc is made from that angle, all right? What arc is made from that angle. For that one, if they don't tell you it's a major arc, you assume it's the minor arc, okay? So if they don't tell you major, you assume the minor arc. If they give you an arc, you're just giving the angle that is made because there's only one option for the angles, okay? Find the measure of the arc or central angle indicated. Assume that lines that appear to be diameters are diameters, okay? So they are asking for the measure of angle DFC. So we want to first find that angle DFC. They said that I can assume diameters. So I'm going to assume this is a diameter, which tells me that from E all the way around to B is a semicircle. What is the measure of a semicircle? 180. So I know all the way around is 180. And I have 2 pieces of that. I have the 75 and the 54, and all I need is this missing piece right here. So how do I find it? Yeah, I'm going to subtract. So I'm going to say 180 minus the 2 pieces that I have to find that missing piece of DFC. All right, which should give you 51 degrees when you do that. So semicircles are made by those diameters. And so anytime you see a diameter in a circle, it's split it up into 2 semicircles, which is probably going to help you with your problem. Let's look at this one. They want me to solve for x. They want me to solve for x. Remember, these are all central angles. So for this 75 here, it actually tells me the piece of the arc as well. That is 75. And along the same lines, this 130 gave me that piece of the arc, which is 130. So when I look at this, I actually have every piece. I have this piece all the way around. I have all the pieces of the circle. So what should all of those add up to? The entire circle should add up to what? 360. So that's what I'm going to do. I'm going to write down every piece, 70 plus the 130, plus the 30, plus the 75, plus 7 plus 8x equals 360. So it's a basic algebra problem at this point. I'm going to add up all of my numbers here. All right. So 312 plus 8x equals 360. Then I'm going to subtract. And then my last step would be to divide. And you should get x equals 6. So for these, you're going to use Pythagorean Theorem, and you're also going to use the fact that that radius is cutting that chord in half. So if the radius hits a chord at a perpendicular, it's bisecting the chord. All right? This is important because they have given us two pieces of it, and sometimes it won't be the same two pieces that you're trying to find. And so it's kind of important that you first remember that all radii are equal, all right, because that's going to come into play with some of these, and that the radius is cutting the chord in half if it hits at a perpendicular. All right, so in this case, we have a right triangle. So we have this right triangle here. They've given us two pieces of the right triangle. We need the third. What theorem am I going to use to solve for the third side of a right triangle? Yeah, so I'm going to use a squared plus b squared equals c squared. Which of these lines is my c? The variable 4.3 or the 10.5? The 10.5. That is most important when you are setting these up. That's the number one mistake I see every time y'all do these. So I don't know my x squared. I know one of my legs, that's 4.3. And I know my hypotenuse, which is 10.5. All right? The other problem that I see when y'all do these is that when you solve for it, and you'll subtract, you'll have the 10.5 squared minus the 4.3 squared. Some of you do that process where you square them and then subtract it over, but then you don't take the square root, okay? So remember, when you're solving with Pythagorean Theorem, you have solved for something squared. So in your calculator, you need to take the root of that answer, because some of you on your quizzes and tests, you leave it as this huge number. And you'll notice that when you actually do this one, your answer is 9.6. All right. And so when you take this subtraction, make sure that you go ahead and do the rest of it and take the square root of that to get your final answer. All right. So you're just using Pythagorean Theorem, but make sure you do all your steps. Make sure you know which one is your C. That's your hypotenuse. That's a very common mistake, to put it in the wrong place. And then make sure at the end you take the square root so that you get to your final answer there. Find the segment length. Assume that lines that appear to be tangent are tangent. So what this is telling us is that this line that looks like it's a tangent line is tangent. And we have a rule about tangent lines and a radius. What do we know about tangent lines and a radius? What do they form? They are perpendicular. So if you have a tangent and a radius, it is perpendicular. So once again, this is really just asking us for the Pythagorean theorem to be used. Now, a couple things I want to point out here. The 6.9 and the 4.6 need to be added together to get that entire hypotenuse length, okay? So you need to add those up. 11.5 is your hypotenuse length here, because you need to add those. And you'll notice they only gave you the hypotenuse. We need one more side of our right triangle. Which side do we know? What other side do we know based on the information that they gave us? Yeah, the other radius. So we also know this side. Because they broke that one up, we also know this side is 6.9 because all of your radii are the same length. So I am trying to solve for this side, which is one of my legs. And I'm going to actually set that up exactly the same way that I did. X squared plus 6.9 squared equals 11.5 squared. And again, you're going to subtract that over. So you are going to have this 11.5 squared minus the 6.9 squared, but you are not done when you do that. Again, you must take the square root of that answer to get your final answer of 9.2. And this is rounded to the nearest tenth. Your whole test is going to be, our quiz is going to be rounded to the nearest tenth. So 9.2 would be your answer there. All right, number 21. They want the perimeter of this triangle, and they've really not given us all the sides. To get perimeter, we have to add up all the sides. But with tangent lines, we know that they are the same distance from the point outside. So when they have given us this 10, we know that if that is 10, then this is 10. And so we know that this piece right here, this small piece, is going to be 10, which leaves 8.9 right here. Now, if we know that piece is 8.9, then we know that this piece is 8.9. And so we know here is 8.9, and we're going to subtract that 9.5. All right. And then if we know that this is 9.5, we know that that is 9.5. And so that actually helps get this third side. 9.5 and 10 is 19.5. And now we can add up all three of our sides. We have 18.4, 18.9, and 19.5. So if we're trying to find the perimeter, we're just going to add each side. We just had to work around the triangle to figure out that third side. So all the pieces are the same. You can see that these two pieces are the same, these two pieces are the same, these two pieces are the same. And then perimeter is just adding your sides up. And so when you do that, you get the 56.8 there, 56.8 when you add all of those up. So when you have two tangents going to the same point, which is what you have right here, then they are equal. This wants you to solve for x. They have given you more information than you need. This is unnecessary information on this one. Learn what you don't need. It is important, okay? Because if you try to use that, you're going to get this problem wrong. The 28.6 is unnecessary information. All you need are the two things that are equal to solve for x. So for this one, I'm going to set the 3x plus 6 equal to the -4 plus 4x. And I am going to solve because all I need to do is solve for x here. So I will subtract my 3x from both sides. I'll get 6 equals -4 plus x. And then I'm going to add my 4 to both sides. And I get x equals 10. And I am done. I did not need to use that other number at all for this. So remember, for arc length, you have to have your radius and you have to have your degree. For arc length, you're going to use your circumference formula and then what part of the circle you have. So remember, it is your angle measure over 360 times 2 pi r. That is your formula here for arc length, all right? So my angle measure is 300. That is out of 360 times 2 pi, and my radius is 18 miles. Plug it in. It says round to the nearest tenth, which means you can put this into your calculator. In your calculator, don't forget that fraction sign is a division. So it's 300 divided by 360 times 2 times pi times 18. All right? And you actually don't need those parentheses if you have a large calculator. It will do order of operations. But if you have a smaller calculator, you may want to do it one step at a time. For this one, you're going to get 94.2. All right, so for these, we are using the information that we have about inscribed angles. All right, inscribed angles. For this, we know that an inscribed angle is half of the arc that it creates. Half of the arc that it creates. So for this one, they've given us a little bit of information. We know that this one right here is 99 degrees. And so we look and see what arc that creates, and it creates this large arc here. This arc that goes all the way around is created by that. So from D all the way to B, this is 99. So what do I need to do to figure out what that blue arc is? I need to take 99 and double it, right? What is 99 if I double it? something like that. So that tells me what this little piece is. So if I know that whole arc is 198, how does that help me find this piece? What can I do? Subtract it, right? Subtract. So that means this is 198 minus 108. What is that? Yeah, just 90, right? Yes? What else does that help me with? I can also find this last piece of this puzzle, can't I? I can find this piece. Why? Why does that help me find that piece? Because I have almost the whole circle. I have 62, 108, and 90. Yes? So how do I find that last piece of the circle? Yeah, add them all together. Add them all together. So I have 360 minus my 90 plus my 108 plus my 62. What does that give me? These together, this is going to be 170 plus 90, 260, right? 360 minus 260, what do I get? There we go. This guy's 100. All right. So far, so good? Yes? All right. What are they asking for? So I've filled out everything that I can fill out about this circle, okay? What are they asking for? Well, they are asking for this little question mark down here. This little question mark is angle D. Well, how do I find angle D? This is angle D right here. This is angle D. I need the angle. I can use the arc that creates it, can't I? Yes? All right, so what do I do? Add these two up, right? What do I get? It's not a trick question. 190, how does that help me find D? D should be exactly half of that, shouldn't it? Yes? If the arc is 190, the angle that makes it is half of it. What's 190 divided by 2? Should be that right there. Yep, 95. So let's look at this one. What have they given us? They've given us this angle W, right? That's the inscribed angle. Where is my X? My X is over here. That inscribed angle makes up this arc. So I automatically know the measure of that arc. Why do I know the measure of the arc if I have the angle? What do I do to the angle to get to the arc? Double it, okay? So I'm going to take that 79 and I am going to multiply by 2. What is 79 if I multiply by 2? 158, all right? That tells me that arc. Does everybody see that? If this is 79, the arc that it made is double, 158. I have these two pieces that should make up that arc. So 84 plus the 10x plus 4 should equal the 158. I have a basic algebra equation here. Add my two pieces. All right. Then I'm going to subtract, right, and solve. This is just basic solving algebra equations here. So 10x equals 70. And then divide. So x should equal 7. X should equal 7.